We have here a table of binomial probabilities, and the part that we've been focusing on calculating is more like what we see in the right-hand side, the probability of a specific sequence with a given number of heads. We did calculate the probability of getting exactly one head from 2 flips. These probabilities here calculate the probability of getting K heads from N flips. So it's much more general. And we're not going to have to do the calculations that are in this table. Hopefully we can look at them and understand them a little bit after the exercise we just went through with much smaller numbers. Now, the way that we calculate probabilities using this table is we would say the probability of K heads is a product of two things. It's a product of the number of ways to choose K from N. So that means, for example, if we're interested in the probability of 2 heads out of 10 flips, we want to look at how many different ways there are to select which 2 of the 10 flips could come up heads. And we multiply that by the probability of a specific sequence with K heads. So for example, if we're looking at 2 heads out of 10 flips, we're looking at a specific sequence like heads, tails, tails, heads, and the rest of them tails. That would be 2 heads total. So when we multiply these together, we get the overall probability of K heads from N flips. So we're going to use this table to figure out what the calculations are and find the probability of flipping 3 heads, so that's K, in a sequence of 10 flips, so that 10 is our N, but this whole table is for N equals 10. So I'm going to, for this, look at K equals 3 and that row and multiply these together. 120 multiplied by 0.4 to the power 7 multiplied by 0.6 to the power 3. On this particular calculator, I can do powers using this x to the y button. So I'm going to start with the 120 times and then 0.4 x to the y 7 times 0.6 x to the y 3, and when I hit the equals, it should follow the correct order of operations and multiply this all together. So we get 0.04246, and if we're going to round that off to, let's say, 3 decimal places, let's just say 0.042. So that's our probability of flipping 3 heads in a sequence of 10 flips. Now, let's take a look at this graph here. This graph is of a binomial distribution for all of these different values of K, and what we just looked at in this graph is this bar here at 3. It has a height of 0.042 probability. If our scale on our y-axis is probability, then this would have height 0.042. Now let's just take a moment to remember a few things. We had a set of hypotheses at the beginning of this, where the null hypothesis was that the probability of flipping a head really is 0.6, and the alternative hypothesis is that the probability of flipping a head is less than 0.6. We also saw that from the sample of 10 flips, we had a sample proportion p hat equals 0.3 because we got heads 3 out of 10 flips. So if this distribution represents the null hypothesis because it's all based on the idea that the probability of flipping a head is 0.6, then the tail going up to p hat equals 0.3, or in this case 3 flips, really corresponds to our p-value. So we need to find this bar height at 2, the bar height at 1, and the bar height at 0, even though those last two look like they aren't there, we want to assume that they are. So we are going to calculate those probabilities based on the table. So let's come back up to our table now and look at 2, 1, and 0 and figure out what those values are so that we can add them all together and get our p-value based on a binomial distribution. Here we've got 45 times 0.4 to the power 8 times 0.6 to the power 2, and filling in the calculations for the other two, we end up with these calculations. The bottom one we already found to be 0.042. So we're going to put these other expressions into a calculator now. And I suggest you go ahead and try this on your own calculator, pause the video, do the calculations, and see that yours match mine so that you can make sure you're entering your expressions correctly and in the correct order in your calculator. Rounding these calculations off at 3 decimal places, we do see that we get some rounding error coming into these computations, but the probabilities should get smaller as we go towards the top. So if 0.042 was our value for k equals 3, then 0.011, 0.002, and for k equals 0, that's not actually a probability of 0. The next digit would be a 1, but given that we're rounding to 3 decimal places, we do actually get all 3 places equal to 0. So when we add those numbers all together, we'll get our left tail p-value. So here we have our p-value of 0.055. We can see that based on the distribution theoretic approach using a binomial distribution, we would fail to reject at the 0.05 level, but we would reject at the 0.1 level or the 10% level. So if we're describing strength of evidence, we would probably call this moderate, right? We have moderate evidence that the actual weighting of this coin is less than the 60% advertised by the manufacturer. Now, we're not going to do full coverage of binomial distributions in this course, but we can at least see how the computations that we do relate to binomial distributions. We'll do some computations like the one that we saw on the first page, the ones we saw on the first page, and the next thing we're going to look at is how to find these numbers, number of ways to choose k from 10, how we would find these numbers in the table. So we will learn the formulas behind that calculation in the next section.